In this video, I am going to discuss about the effect of rotation of coordinate axis on Lorentz transformation. As all of you can see, I have started with the basic Lorentz transformation equations that are given by x dash is equals to x minus vt by root over 1 minus v square by c square, y dash should be equal to y, z dash is equal to z, t dash is equals to t minus vx by c square whole divided by root over 1 minus v square by c square. Now in my first video I have described how to obtain all these equations, so if you have any question regarding the derivation of these component expressions, then you can consult my first video. Now let us assume that the coordinate axis be rotated by means of an angle theta. So before rotation, if we consider it was x-axis and y-axis, then after rotation simply we can say it will be modified into x dash and y dash axis respectively. Now we can use the concept of elementary coordinate geometry to find out the relationship between old coordinate system and new coordinate system, and that's why I have written equation number 4. X dash is equals to x cos theta plus y sin theta, y dash is equals to minus x sin theta plus y cos theta, z dash will be z, t dash will be t. So here we have assumed that the rotation takes place in the xy plane regarding z axis. Now instead of considering rotation in the xy plane, if we want to consider the rotation in the xict plane, that means we are considering an imaginary plane by means of an imaginary angle theta is equals to I phi, then these equations should be modified to some extent, and for that purpose you can see I have written x dash is equals to x cos I phi. As mentioned earlier, we are considering xict plane, so y should be replaced by what? Ict, then sin I phi. Now using the property of hyperbolic function, we can write the next line, that is x cos hyperbolic phi plus I into ict sin hyperbolic phi. Simple calculation will give you equation number 5. Also y dash should be equal to y, z dash is equals to z. These two component equations will give you equation number 6. Now again we have to modify the last component equation by considering y dash is equals to ict dash minus x sin of I phi plus ict cos of I phi. Because we are considering xict plane, that's why we are modifying the component expressions like this. Now here in the next part you will see I have written ict dash is equal to ict cos of I phi minus x sin of I phi, and from here we can easily, using the concept of hyperbolic function, we will get the next possible line. Also you can see I have cancelled out I from both sides, so that we have obtained equation number 7. Now equation 5, 6 and 7 are collectively termed as Lorentz rotation of axis. Now also if you observe equation 5 and 7, that we can put these two equations into a modified structure, that is by means of a matrix. Now how to consider this matrix? Simply we can use the basic criteria, x dash is equals to capital X, where capital X dash can be considered as a column matrix of the form x dash ct dash, that is the left hand side of equation number 5 and 7. On the right hand side, capital X will be nothing but xct, again another column matrix, and simply for the coefficient matrix, that is capital A, can be treated like the coefficients of x and ct. For example, in equation 7 you can see coefficient of x is what? Minus sin hyperbolic phi. Coefficient of ct is sin cos hyperbolic phi. So in this second row I have written coefficient of x here, coefficient of ct here. Obviously whatever you can obtain coefficient of x and coefficient of ct from equation 5, that should be written in the first row. So this is the modified structure, or better to say the matrix form, which can be obtained by rotating the coordinate axis by means of a suitable angle theta is equals to I phi. Now this type of question can come in your university question in the following form. For that purpose I have written note 1, that is alternative question of the above article is like this. You may be asked to show that the Lorentz transformation equations can be put in the following form. For reference I have given one such question here. Say this question came in 2014 under Calcutta University. You can find out similar questions in other university question papers also. Now in note 2 I have discussed about another important observation. Say this is given by equation number 8. Here you can see I have written cos hyperbolic phi is equals to like this. So accordingly sin hyperbolic phi can be obtained in this manner. Now if we use the value of equation number 5, whatever we have obtained earlier, then easily we can compute the value of x dash, which is supposed to be x minus vt by root over 1 minus v square by c square. Actually, you can take the help of this equation. X dash is equals to x cos hyperbolic phi minus ct sin hyperbolic phi. Now in this equation, if you put the values of cos hyperbolic phi and sin hyperbolic phi, then after simplification you will be able to get the expression corresponding to this, x minus vt by root over 1 minus v square by c square. Similarly, if you consider equation number 7, then also you can find out another modified structure after simplification, which ultimately leads to t dash is equals to like this, t minus vx by c square by root over 1 minus v square by c square. Also y dash remains y, z dash remains z. So if we choose cos hyperbolic phi and sin hyperbolic phi like this, then we can see actually the modified structure reduces to the familiar Lorentz transformation. So in this article we have discussed about the impact of rotation on Lorentz transformation equations, and from examination point of view this article is very important, and hopefully in this video you will find your desired answer. Thank you.